Welcome to the session on System Tools and Utility Programs. Software is a generic term for an organized collection of computer data and instructions. As we have seen earlier, there are two types of software, application software and system software. Application software helps users to solve a particular problem or carry out a specific task. A word processor is an example of application software. System software coordinates the activities and functions of hardware and software, and it controls the operations of computer hardware. A computer's operating system is an example of system software. Operating systems control the computer hardware and act as an interface for the users. The functions of operating system such as process management, memory management, device management and information management etc. were discussed in the previous session. System software also includes utility software. Utility software helps to manage, maintain and control computer resources. Operating systems typically contain the necessary tools for this, but separate utility programs can provide improved functionality. Utility software is often somewhat technical and targeted at users with a solid knowledge of computers. System software. System software refers to the files and programs that make up computer's operating system. System files include libraries of functions, system services, drivers for printers and other hardware, system preferences and other configuration files. Since system software runs at the most basic level of computer, it is called low-level software. It generates the user interface and allows the operating system to interact with the hardware. Some system software is used directly by users and other system software works in the background. System software can allow users to interact directly with the hardware functionality like the device manager and many of the utilities found in the control panel. The most important feature of system software include closeness to the system, fast speed, difficult to manipulate, written in low-level language, difficult to design, etc. System software can be categorized under the following. Operating system handles the communication between hardware, system programs and other applications. Device driver enables device communication with operating system and other programs. Firmware enables device control and identification. Translator translates high-level language to low-level machine codes. Utility ensures optimum functionality of devices and applications. Operating system. We have already seen the basic functionalities of an operating system. However, we will have a quick look on the important concepts regarding it. The operating system is a type of system software kernel that sits between computer hardware and end user. It is installed first on a computer to allow devices and applications to be identified and therefore functional. System software is the first layer of software to be loaded into memory every time a computer is powered up. Suppose a user wants to write and print a report to an attached printer. A word processing application is required to accomplish this task. Data input is done using a keyboard or other input devices and then displayed on the monitor. The prepared data is then sent to the printer. In order for the word processor, keyboard and printer to accomplish this task, they must work with the operating system which controls input and output functions, memory management and printer spooling. Today, the user interacts with the operating system through the graphical user interface or GUI on a monitor or touchscreen interface. The desktop in modern operating systems is a graphical workspace which contains menus, icons and apps that are manipulated by the user through a mouse-driven cursor or the touch of a finger. The disk operating system or DOS was a popular interface used in 1980s. Types of operating systems. Real-time operating system. It is installed in special purpose embedded systems like robots, cars and modems. single user and single task operating system. These are installed on single user devices like phones. Single user and multitask operating system. They are installed on contemporary personal computers. Multi-user operating systems. It is installed in network environments where many users have to share resources. Servers operating systems are examples of multi-user operating systems. Network operating systems. It is used to share resources such as files, printers, etc. in a network setup. Internet web operating system. It is designed to run on the browser, that is online. Mobile operating system. It is designed to run on mobile phones, tablets and other mobile devices. Functions of operating systems. They provide the interface between the user and hardware through GUI. Manages and allocates memory space for applications. Processes the management of applications, input-output devices and instructions. Configures and manages internal and peripheral devices. Manages single or multi-user storage in local and network computers. Security management of files and applications. Detects, installs and troubleshoots devices. Monitors system performance through Task Manager and other tools. Produce error messages and troubleshooting options. Implement interface for network communication. Manages printers in single or multi-user systems. Internal or network file management. Examples of operating systems. Popular operating systems for computers are Windows 10, Mac OS X, Linux, etc. Popular network server operating systems are Ubuntu Server, Windows Server, Red Hat Enterprise. Popular internet or web operating systems are Chrome OS, Club Linux, Remix OS. Popular mobile operating systems are iPhone OS, Android OS, Windows Phone OS, etc. Device drivers. Driver software is a type of system software which brings computer devices and peripherals to life. Drivers make it possible for all connected components and external add-ons perform their intended task and as directed by the operating system. Without drivers, the operating system would not assign any duties. Examples of devices which require drivers are mouse, keyboard, sound card, display card, network card, printer, etc. Usually, the operating system ships with drivers for most devices already in the market. By default, input devices such as mouse and keyboard will have their drivers installed. They may never require third-party installations. If a device is newer than the operating system, the user may have to download drivers from manufacturer websites or alternative sources. Firmware. Firmware is the operational software embedded within a flash, ROM or EEPROM memory chips for the OS to identify it. It directly manages and controls all activities of any single hardware. Traditionally, firmware used to mean fixed software as denoted by the word firm. It was installed on non-volatile chips and could be upgraded only by swapping them with new pre-programmed chips. This was done to differentiate them from high-level software which could be updated without having to swap components. Today, firmware is stored in flash chips which can be upgraded without swapping semiconductor chips. BIOS and UEFI. The most important firmware in computers today is installed by the manufacturer on the motherboard and can be accessed through the old BIOS basic input-output system or the new UEFI Unified Extended Firmware Interface platforms. It is the configuration interface which loads first when the computer is powered up and is going through POST, that is power on self-test. The motherboard firmware starts by waking up all the hardware and ensures that components like the processor, memory and disk drivers are operational. If all the crucial components are fine, it will run the bootloader which will load the operating system. If the random access memory is faulty, the BIOS will not allow the computer to boot up. The user can change the BIOS and UEFI settings by pressing special keys, a function key, delete or the escape key at boot up to load the configuration page. The user can configure security, boot order, time and other options in the page that pops up. Though they work differently, firmware complements drivers in a few ways. Both give identity to hardware devices, with the latter making the operating system see the device. The major difference between the two is that firmware will always reside within the device while drivers will install within the operating system. Firmware upgrades come from the device manufacturer, not the operating system manufacturer. They are necessary if the user wants computer hardware to receive new hardware and software support. Firmware will make it possible for devices to work better with the old and new operating systems and applications. Almost all devices and peripherals are embedded with firmware. Network card, TV tuner, router, scanner or monitor and examples of devices which have firmware installed on them. Programming language translators. These are intermediate programs relied on by software programmers to translate high-level language source code to machine language code. The former is a collection of programming languages that are easy for humans to comprehend and code, that is Java, C++, Python, PHP, BASIC, etc. The latter is a complex code only understood by the processor. Popular language translators are compilers, interpreters, assemblers, linkers, loaders and macros. They are usually designed by computer manufacturers. Translator programs may perform a complete translation of program codes or translate every other instruction at a time. Machine code is written in a number system of base 2, written out in zeros or ones. This is the lowest level language possible. While seemingly meaningless to humans, the zeros and ones are actually sequenced intelligently by the processor to refer to every conceivable human code and word. Besides simplifying the work of software developers, translators help in various design tasks. They identify syntax errors during translation, thus allowing changes to be made to the code. Provide diagnostic reports whenever the code rules are not followed. Allocate data storage for the program. List both source code and program details. A brief description of the compilers, interpreters, assemblers, linkers, loaders and macros are given below. Compiler. A compiler is a software that translates the code written in one language to some other language without changing the meaning of the program. The compiler is also said to make the target code efficient and optimized in terms of time and space. The compiler performs almost all of the following operations during compilation: pre-processing, lexical analysis, parsing, semantic analysis, that is syntax deducted translation, conversion of input programs to an intermediate representation, code optimization and code generation. Examples of compiler may include GCC, that is the C compiler, G++ for C++ compiler, Java C for Java compiler, etc. Interpreter. An interpreter is a computer program that directly executes, that is, it performs instructions written in a programming or scripting language. Interpreter do not require the program to be previously compiled into a machine language program. An interpreter translates high-level instructions into an intermediate form which is then executed immediately. Interpreters are fast as it does not need to go through the compilation stage during which machine instructions are generated. Interpreter continuously translates the program until the first error is met. If an error comes, it stops executing. Hence, debugging is easy. Examples may include Ruby, Python, PHP, etc. Assembler. An assembler is a program that converts assembly language into machine code. It takes the basic commands and operations and converts them into binary code specific to a type of processor. Assemblers produce executable code that's similar to compilers. However, assemblers are more simplistic since they only convert low-level code, that is assembly language, to machine code. Since each assembly language is designed for a specific processor, assembling a program is performed using a simple one-to-one mapping from assembly code to machine code. On the other hand, compilers must convert generic high-level source code into machine code for a specific processor. Linker. Linker is a program in a system which helps to link an object modules of program into single object file. It performs the process of linking. Linkers are also called link editors. Linking is the process of collecting and maintaining pieces of code and data into a single file. Linker also link a particular module into system library. It takes object modules from assembler as input and form executable file as output for loader. Linking is performed at both compile time when the source code is translated into machine code and load time when the program is loaded into memory by the loader. Linking is performed at the last step in compiling a program. Linking is of two types: static linking and dynamic linking. Static linking. It is performed during the compilation of source program. Linking is performed before execution in static linking. It takes collection of relocatable object files and command line argument and generate fully linked object files that can be loaded and run. Static linker performs two major tasks. Symbol resolution. It associates each symbol reference with exactly one symbol definition. Every symbol have predefined task. Relocation. It relocates code and data section and modifies symbol references to the relocated memory location. The linker copies all library routines used in the program into executable images. As a result, it requires more memory space. Hence, it does not require the presence of library on the system when it is run. So, it is faster and more portable. No failure chances and less error chance. Dynamic linking. Dynamic linking is performed during the runtime. This linking is accomplished by placing the name of a shareable library in the executable image. There is more chances of errors and failure chances. It requires less memory space as multiple programs can share a single copy of the library. Loader. As the program that has to be executed currently must reside in the main memory of the computer. It is the responsibility of the loader, a program in an operating system, to load the executable file or module of a program generated by the linker to main memory for execution. It allocates memory space to the executable module in main memory. There are three kinds of loading approaches: absolute loading, relocatable loading, and dynamic runtime loading. Absolute loading. This approach loads the executable file of a program into the same main memory location each time. But it has some disadvantages, like a programmer must be aware of the assignment strategy for loading the modules to the main memory. In case a program is to be modified involving some insertion and deletion in the program, then all the addresses of the program have to be altered. Relocatable loading. In this approach, the compiler or assembler does not produce actual main memory address. It produces the relative addresses. Dynamic runtime loading. In this approach, the absolute address for a program is generated when an instruction of an executable module is actually executed. It is very flexible. The loadable module or executable module can be loaded into any region of main memory. The executing program can be interrupted in between and can be swapped out to the disk and back to main memory, this time at a different main memory address. Macros. A macro is an extension to the basic assembler language. They provide a means for generating a commonly used sequence of assembler instructions or statements. The sequence of instructions or statements will be coded one time within the macro definition. Whenever the sequence is needed within a program, the macro will be called. Macros allow a programmer to define pseudo operations, typically operations that are generally desirable, are not implemented as a part of the processor instruction and can be implemented as a sequence of instructions. Each use of a macro generates new program instructions. The macro has the effect of automating writing the program. Macros can be defined used in many programming languages like C, C++, etc. Example macro in C programming. Macros are commonly used in C to define small snippets of code. If the macro has parameters, they are substituted into the macro body during expansion. Thus, a C macro can mimic a C function. The usual reason for doing this is to avoid the overhead of a function call in simple cases where the code is lightweight enough that the function call overhead has a significant impact on performance. Utility programs. A utility or software utility is computer system software intended to analyze, configure, monitor, or help maintain a computer. Typically, a utility is smaller than a standard program in size and may be included with an operating system or installed separately. Utility software should be contrasted with application software, which allows users to do things like creating text documents, playing games, listening to music, or surfing the web. Rather than providing these kinds of user-oriented or output-oriented functionality, utility software usually focuses on how the computer infrastructure, including the computer hardware, operating system, application software, and data storage, operates. Due to this focus, some utilities are rather technical and targeted at people with an advanced level of computer knowledge. Others are commonly used by all the users. Most utilities are highly specialized and designed to perform only a single task or a small range of tasks. However, there are also some utility suites that combine several features in one piece of software. Most major operating systems come with several pre-installed utilities. Some of the most popular utility software are given here: antivirus, file management tools, compression tools, disk cleanup, disk defragmenter, backup, registry cleaners, and file splitters. Antivirus. A virus can be defined as a malicious program that attaches itself to a host program and makes multiple copies of itself, slowing down, corrupting, or destroying the system. A software that assists the operating system in providing virus-free environment to the user is called antivirus. An antivirus scans the system for any virus and, if defected, gets rid of it by deleting or isolating it. It can detect many types of virus like boot virus, Trojan, worm, spyware, etc. When any external storage devices like USB drive is attached to the system, antivirus software scans it and gives an alert if a virus is detected. We can set up our system for periodic scans or scan whenever you feel the need. A combination of both the techniques is advisable to keep your system virus-free. File management tools. As we know, file management is an important function of operating systems, as all data and instructions are stored in the computer in the form of files. Utility software providing regular file management tasks like browse, search, update, preview, etc. are called the file management tools. Windows Explorer in Windows operating system, Google Desktop, Directory Opus, Double Commander, etc. are examples of such tools. Compression tools. Storage space is always at a premium in computer systems. So, operating systems are always looking at ways to minimize the amount of storage space taken by files. Compression tools are utilities that assist operating systems in shortening files so that they take less space. After compression, files are stored in a different format and cannot be read or edited directly. It needs to be uncompressed before it can be accessed for further use. Some of the popular compression tools are WinRAR, pzip and Unarchiver, etc. Disk cleanup. Disk cleanup tools assist users in freeing up disk space. The software scans hard disk to find files that are no longer used and frees up space by deleting them. Disk defragmenter. Disk defragmenter is a disk management utility that increases file access speeds by rearranging fragmented files on contiguous locations. Large files are broken down into fragments and may be stored in non-contiguous locations if contiguous ones are not available. When such files are accessed by the user, access speed is slow due to fragmentation. Disk defragmenter utility scans the hard disk and tries to assemble file fragments so that they may be stored in contiguous locations. Backup. Backup utility enables backing up of files, folders, databases or complete disk. Backups are taken so that data may be restored in case of data loss. Backup is a service provided by all operating systems. In standalone systems, backup may be taken in the same or different drive. In case of networked systems, backup may be done on backup servers. Registry cleaners. Registry cleaners are programs that allow for us to scan our computer for any errors in the registry, which is a collection of the code computer files that are essential to perform and functionality, and replace them if needed. Registry cleaners are widely available on the internet and give a significant upper hand when cleaning up the mess that a virus or the other malware has left on our computer. Likewise, some otherwise safe computers can cause errors in the registry without intending to. Registry files can also be corrupted if the user unknowingly deletes or modifies a file in the registry. This usually occurs when an inexperienced user tries to fix their computer and inevitably causes more damage than before. File splitters. File splitters are programs that allow to break a file into smaller pieces in order to store or send files. File splitters often come in handy because many online storage services, including email attachments, limit us to specific file size that can be transferred at one time, even though files often exceed these limits. File splitters allow to break the file into two or more pieces, send them simultaneously, and then piece them back together when we are ready to use the file again. A good file splitter is File Splits. It allows to break a file of any size into multiple pieces and then rejoin the files together just as easily. Software is essential for a computer to work. The computer is a machine that works only according to the given instruction or software. This can be divided into two, such as system software that support the basic functionalities of a computer system and application software that is used to interact with the system for specific applications. Utility software is system software designed to help to analyze, configure, optimize or maintain a computer. It is used to support the computer infrastructure, in contrast to application software, which is aimed at directly performing tasks that benefit ordinary users. Hence, we have discussed language translators, linkers, loaders and other important system utilities such as antivirus, debuggers, etc. Hope you enjoy this session. See you next time. Until then, bye.